We are now in Unit 4, which is linear equations, and this is really the beginning of algebra, okay? Because algebra is all about manipulating numbers and equations, so we're going to be starting that now. So lesson 1 through 3 of Unit 4 is writing equations using symbols, and then also talking about things that are linear and nonlinear. Our first vocab word is a variable, and I know you've probably heard that because it's very common in math. So a variable is essentially some symbol, normally a letter, that we're going to use in place of a number. So a lot of times you'll see like solve for x or solve for y, and that is the variable. So let's get that down. So a variable is a character that represents a number, and it's normally a letter. So let's get down some examples. Of course, the most common one is x. You also see y a lot, and pretty much any letter. So you can throw in a couple that you like. The next vocab word is equation. And an equation means it's something with an equal sign. So x equals 5 would be an equation, but x by itself is not an equation. There has to be an equal sign. So let's get that down. So you can write a different example if you would like to. We can stick with something simple. X equals 5 is an equation because there's an equal sign. I don't know, maybe something more complicated. But an equation is different than an expression, and that's our next vocab word. An expression is essentially one side of the equal sign. So let's get that down. It's just one side of an equation. So actually, if we take a look back at our equations that we just previously wrote, 3y plus 2 is an expression. 7 is an expression. Okay, so it's just that part, but it doesn't actually equal anything out. So those are some base words that will be coming up a lot in this unit. What we're now going to look at is translating words into symbols. So essentially taking kind of like a word problem and turning it into an equation or into an expression that we can work with. So if we're looking for essentially addition, if we want to say that it's addition, these are the words that you're going to see that you're going to translate to be that plus sign. So here are some words that if you see it in a word problem, you're going to want to translate into being addition, into that plus sign. So if you see it saying sum, we want the sum of 5 and 7, you're going to be adding together 5 and 7. Or maybe added to, 3 is added to 5. You're going to be adding those together. Okay? So these are the types of things that you'll see popping up that we're going to translate into addition. Now let's take a look at the ones that you want to translate into subtraction. All right, so here are the ones that we're going to translate into subtraction. So if you see something like less than, 3 less than 7, you're going to want to be doing subtraction. Or the difference between 5 and 2, that's subtraction. Now I put a little star here to let you know that you want to be careful about the order. So subtraction is really the only one you need to worry about. So if you're thinking about 3 less than 7, you're not going 3 minus 7, you're going 7 minus 3. And subtraction is really the only one that you have to watch out and make sure that you don't need to reverse your numbers. Let's take a look at division. So if you want to put another sign in there to remember which one that is, so a slash or division sign. For division, the words that you're going to see is quotient, because quotient is the end result of division, divided by, so maybe 5 divided by 7, per, like miles per hour, is actually division. All right, let's get down multiplication. And multiplication is actually normally pretty easy to see which one it is. The only one that's really one that you may not know already is of. So 3% of 7, you're multiplying those. Obviously, if it says time, product, multiplied by, that is multiplication. For twice, it's very specific that it's a multiplication by 2. And I put that in there because our book does bring that up. And then equal sign, it's going to be some sort of version of is, essentially. So you might see it as is. So if you see something like 3 plus 2 is, that is it's saying that that's where the equal sign goes. So now let's actually take a look at doing some examples. All right, we're going to start with a couple easy examples of translating into symbols, and then we'll do a couple tougher ones as well. So the first one says 5 more than 2 is 7. So let's just do a direct translation. 5 obviously means 5. More than, if we look back up at top, we know that more than meant addition. So that's going to translate into plus. 2 translates obviously into 2. Is translates into equal. just like we saw from above, and 7 translates into 7. So we just translated the words into an equation, and that equation makes sense. Yeah, 5 plus 2 equals 7. So let's take a look now. 3 less than 7 is 4. Now, if we do a direct translation, 3 less than is negative, 7 means equal, and 4. Ooh, wait, that's not right. 3 minus 7 is not 4. So again, this goes back to how you need to be very careful with the subtraction sign and what it means. So 3 less than 7 is not 3 minus 7. You're going 3 less. Your starting point is 7. Then you're going 3 less from there. So you actually need to reverse these. 7 minus 3. Okay? So this less than is going to tell you to essentially reverse your numbers. Okay? And you always want to really watch for that. Let's take a look at the next 2 examples. In our next example, Tommy had 3 bananas, then got 6 more. How many bananas does he have? So he had 3 bananas. Okay, so we have a 3. Then got 6 more. So that more means that we have an addition sign somewhere, and we also have a 6. So in this case, things are not very directly translated. We can't do a direct down and then have an equation. We essentially need to kind of think it through. Well, he started with 3 and then got more. So maybe it should be 3 plus. So that's this. He started with 3, got more, and how many he got more was 6. And so then we can solve it if we want to. But at this stage, we can just leave it like that. It's not actually asking for us to solve. Now let's take a look at the next one. The difference between, difference between means we're working with subtraction. 2 numbers, so we just have 2 numbers. It doesn't tell us what. So whenever you see it say 2 numbers, it's essentially saying choose whatever variable you want. And I'm going to choose M and N. You can choose any ones you want. So 2 numbers, M, and another one, N. Okay. So we're doing the difference between those 2 is, so we have an equal sign, 1/3 of 7. So 1/3, of course, is a third. Of means times, and 7, of course, means 7. So we have kind of the workings of an equation here. It kind of looks pretty similar. I think this side's okay. We have 1/3 times 7 equals okay. We need to work out this side, though. The difference between 2 numbers. Well, it would make sense if we can just take that subtraction sign and throw it between. So if we rewrite this equation, we take our 2 numbers, throw that subtraction sign between because we're finding the difference between them. So it makes sense that the subtraction sign goes between them. And then throw in the rest of our equation, 1/3 of 7. And remember, if you want to write that as a dot, that's fine too. Now we're going to take a look at what it means if something is linear or nonlinear. And those sound like very complicated words, but it's actually very simple. Things that are linear, linear means line, essentially. So it means if I graph it, it will be a line. It will be a straight line. So let's get that down. So we're, of course, talking about equations, that if I graph this equation, it's going to give me a straight line. But, of course, then the actual lines themselves can be defined as linear or nonlinear, if they're straight or not. If they're curvy, then they're nonlinear. So I always put this in the beginning just so that this is the easiest way for you to remember. Linear means line. That's it. Okay? If you can remember that, you normally remember the rest of it. So nonlinear, of course, is not a straight line. And so it could be that when it's graphed, it's going to be parabola, it can be curly, it can be exponential. So it can be pretty much anything else. It's not a straight line. So now let's fill in this blank. Both blank and blank can be linear or nonlinear. So it's both expressions and equations. So an expression can be linear or nonlinear, and an equation can be linear or nonlinear. Okay, so now let's fill this in. You can tell if an expression or equation is linear by looking at the numbers and symbols and looking for powers. And you'll remember from Unit 1 that powers were essentially talking about exponents. But not just all exponents, square roots are also counting as powers. So if there are any powers, then it's nonlinear. Okay, so if there are any powers or exponents, we can call them exponents. So if any powers or exponents and square roots, cube roots, all of those are included in powers, then you have something that's nonlinear. So let's take a look at some examples and actually see if they are linear or nonlinear and see if we can identify those. Okay, so again, even though some of these might look really confusing to you and you don't know what to do with it, that's not what matters right now. We're not trying to solve anything. We're just going to say if they're linear or nonlinear. So if there is a power involved or a square root or something like that, then it's nonlinear. And then everything else is linear. So this first example, 5x plus 3, there's no squaring, cubing, or anything going on right now. It's a simple x with nothing attached. So that is linear. This next one, there's no powers involved, and there's not even any variables, okay? Because the powers have to be on a variable for it to be nonlinear. So this one, of course, is linear. This next one over here, red flag, we have an x squared. So automatically, it's going to be nonlinear. And if you want to circle or highlight or something like that, because of that square, that's why it's nonlinear. Next one down here, once again, we have an x being squared, so that means it's nonlinear. Next one. Looks a little nasty. We got some decimals and we got multiple x's, but nothing's being raised to a power, so it's still linear. Over here, we have x over 2 all raised to a third power, so that third power says it's nonlinear. Back down here, we have some parentheses, but that's okay. They're not powers, so even if though it's x plus 2 all times 11, that's okay. Just because it looks a little nasty, it's still linear. There's no powers there. Okay, back to the middle. Looks a little complicated, but there's no powers anywhere in here. There's no square rooting going on, so this is still linear. And last one over here, there's a negative power. We haven't learned that yet, but it's still a power, so this is nonlinear. So hopefully that made it a little bit clear. As long as if there's a power or square rooting or any of that sort of stuff going on, it's nonlinear. So now let's move on. We're getting into solving for x, essentially, solving for unknowns. We're not going to start that until the next set of lessons, but this one is just going to be an introduction into that idea. So here we have a bunch of equations, and it's essentially asking if something could be a solution, and we're going to see if that's true. So we're not having to solve these yet. We're not to that point yet. We're just seeing if something could be a solution, and we're just essentially saying yes or no. All right, so we're starting with x plus 5 equals 7. It's asking, can x equal 3? And the fastest way to figure that out is to throw 3 in and see if it works. So if we put 3 in for x, let's see if it works. Well, 3 plus 5 is 8. Whoa, 8 does not equal 7. So no, x can't equal 3. X can be something else, and I know a lot of you can probably already see what x should be, but again, we're not quite to that step. That's the next set of lessons. Let's take a look at our next one. Y divided by 2 minus 3 equals a negative 2. Oof, that's a little nasty looking, but let's see if y can equal 2. So let's throw that in. So we have a 2 being divided by 2, then minus 3 equals negative 2. Okay. Well, 2 over 2 equals 1. Put out the rest of the equation. 1 minus 3 equals negative 2. Oh yeah, that's sounding about right. 1 minus 3 is a negative 2. So this one worked. So yeah, y equals 2 in this case. All right, our next one is something squared. So n squared minus 3 equals 22. So can n equal 25? Let's find out. So put in 25. Okay. So we have 25 squared minus 3 equals 22. You might already be thinking that's definitely not, can't be, because 25 squared is a really, really big number. 625, minus 3. Yeah, minusing 3 is not enough to bring it down to 22, so this is definitely a no. Let's take a look at our last one. We have a 6 minus f equals 18. So can f equal a negative 12? Let's find out. So 6 minus negative 12 equals 18. Right? Well, we're not very good at negatives, so we need to keep working with this. If we have two negatives, that becomes a positive, because if you subtract a negative, you're now going positive. So we have 6 plus 12 equals 18. Oh yeah, that works. So yes, f can equal negative 12. And that's it for this lesson. And again, so